So, welcome back, everyone. In today's lecture, we will continue from where we left off from the previous lecture, where we started talking about 5G security. And I remember we reached to this slide discussing composition of 5G security. So, 5G and beyond 5G security can be classified into four directions. The first direction is the pre-5G issues, the pre-5G security issues, which are the security issues that existed in the previous generations, like 4G, 3G. They still exist in 5G, and we need to handle them and to find good approaches to overcome the threats that are caused by these kind of issues. We also have issues related to network softwareization. The softwareization and virtualization in 5G is more. So these are the things that we also need to take care of and handle in 5G networks, because more softwareization means more attacks that can happen at the application layer. Attacks that can exploit the way you code your program, the way you organize your database, the way you build your systems. And these things can be exploited for attacks, for breaches, and therefore good mechanisms and good robust techniques should be developed in order to avoid such kind of attacks. And third, we have issues related to new technologies that were introduced in 5G and didn't exist before in the previous generations, like massive MIMO, new numerologies, new bands, millimeter wave communication. We have the splitting behavior in 5G, the disaggregation, the open RAN possibility in 5G, where you isolate the hardware from the software, and you can use open source softwares on top of off-the-shelf hardware devices to build 5G networks. So all these things should be handled properly. And finally, we have issues related to new verticals. So now 5G is not just for improving the speed of the internet or improving the data rate, but it's also used in most other industries like manufacturing, agriculture, in hospitals, in schools, and for a new type of application like remote telemedicine, for self-driving cars, for smart architecture, for all these Internet of Things related applications. 5G can be integrated with them, can be the backbone connectivity technology for providing robust communication systems. So again, security should be handled properly here. The pre-5G security issues, 5G will be vulnerable to pre-5G attacks like mobileware attacks such as denial of service, botnet, APT attacks, and so on. We have the physical layer attacks such as jamming, the signal interference, eavesdropping, man in the middle. We also have roaming frauds and IP hijacking attacks. We have rogue base station attacks. Rogue base station attacks, it's like phishing or impersonation attacks, where a fake base station claims to be a real one and asks the users in the coverage range of its signal to associate with it, so that they can start communicating via this rogue fake illegal base station. So this is kind of impersonation and very dangerous attack, because all the traffic will be going through this fake base station. We have the IMSI catcher also attack that intercepts mobile phone traffic and tracking location data of mobile phone users. We have also attacks via non-3GPP networks such as Wi-Fi, WiMAX, CDMA 2000, WLAN, or fixed networks. Now, the security impact of network softwareization in 5G, this is one of the directions that's new compared to the previous generation, because the architecture in 5G is more focused on softwareization. Network softwareization in 5G will introduce new security issues than 4G. These issues can be listed as follows. First, we have open architecture introduces more attacks. I told you we have many open source tools, many open source software that really can, many open source software programs that can be used to build simple 5G networks in any place you want and deploy it by yourself on top of off-the-shelf servers or compute devices, or even on top of Raspberry Pi. So this openness introduces new challenges in terms of security, because that code is available to everybody. It's not like the previous generations like 4G and this, where it's really hard to find an open source code for the whole stack of 5G of the 5G network. The second point, no implicit security due to the lack of know-how. No implicit security. There is no security specific requirements just because of softwareization. Still, we are following the traditional way of implementing and applying security. This is a risky thing also. So we need to pay more attention to address this as well. And the third point here, we have software-based system. Again, this is related to the previous point, to the first point, because they are easy to hack than hardware-based systems. For example, in the first generation and second generation, the solution was more focused on the hardware rather than on the software. But now in 5G, uh, you don't have a software coupled with hardware. Like, you don't buy hardware devices essentially. You just buy software sometimes. And the software can be proprietary. You need to pay for it. Or it could be an open source software. I can teach you how to build a 5G network. If you have the devices with you, the devices that transmit and receive, plus a compute device like a server or Raspberry Pi or your laptop. You connect them with each other, install the proper softwares, you now have a 5G network with the proper antennas and power amplifiers. This was not even thinkable of, not even imaginable in the previous generations. Like telling somebody you can set up a complete whole network by yourself, 4G, 5G. This is not even in the dreams, because it was just big companies can do this, just big companies. But now, if you have the knowledge of know how to implement the network, you can do it yourself, because the open source tools that enable you to build such a network is available. They are available, and you can just buy off-the-shelf hardware device, install these softwares on top of these off-the-shelf hardware devices, configure them properly, have deep knowledge in the settings of the softwares and deep knowledge in configuring and customizing the software in such a way that it meets your requirements, and then you have a ready to launch 5G network. This is really something really outstanding, and it was not possible before. Uh, for those of you who are interested maybe to do a project on something related to that, like building a 5G network from scratch, and then investigating its security and testing the network, I can maybe share some material with you and tutorials that can help you step by step do that by yourself. So the fourth point says no perimeter security or physical security due to virtualization. So virtualization makes it even more vulnerable to security attacks, because now on top of the same hardware, you are creating multiple machines. You are dividing the resources of the hardware you have in terms of CPU, RAM, and other like hardware space and size and so on. And you have just one hardware, but effectively the network is seeing if you are using virtual machine and using virtualization to build multiple separate hosts, you are seeing multiple of them, but they are all sharing the same hardware. So if there is an attack on this hardware, it will not just impact one device, it will impact all the hosts, all the devices that are built on top of that hardware. So physical security, not a physical layer, physical security here I mean the device itself, protecting it from any damage, any physical damage or any malfunction. And last point, fast deployment of virtualized element with omit proper security testing, which is related to the previous point as well. So as we said, the new technologies introducing new vulnerabilities to 5G. The new technologies that exist in 5G at the core level, in the core network, we have something called network slicing. Slicing like dividing the network resources and network assets into categories, and each category is responsible for something. We have multiple access edge computing, where you move the computing power from centralized servers into the edge, into the base stations to make them closer to the users. And we have network function virtualization, where you, on top of one hardware, you create multiple hosts, multiple devices by sharing the resources among them and allocating, assigning certain certain resources to each host based on the requirements of the application that will run on it. And we have software-defined networking, where you have the same router, the same switch can be configured to do any functionality you want remotely from a centralized server. You don't need to be physically close to the software, to the device, in order to configure it and ask it to do the job you want it to do it. And plus, you can update these settings, update these configuration and customization remotely from a remote server that controls it. Again, the concept here is one hardware, and you can configure it the way you want by remotely from a centralized server by from a software basically. We have also something called software-defined radio. So the software-defined radio is in the radio interface. You have one device, let's say, one device, a radio device that got oscillator, power amplifier, and antennas and so on. And you can connect the software with it. And by using this software, you can change the frequency, change the band, change the settings you want. So you're kind of creating a new device by just changing the parameters inside it. In the old days, in the previous generations, if we were to just change the frequency or change the band, we needed to build a new device, kind of. But with softwareization, with the same device, you are able to make it work at different frequencies, different bands, behave in different ways just by the customization of the software that's linked with that device. So software-defined networking, again, is the physical separation of the network control plane from the forwarding plane, and where a control plane controls several devices. This is also the much more comprehensive definition of software-defined networking. Here, when we say the control plane, these are the commands, the settings that you use to control the behavior of your router or switch. And for the data plane, or forwarding plane, this is the data. I mean, this is it has nothing to do with controlling or signaling or routing or anything. It's just data waiting to be controlled by the network control plane. So in the old day, traditional, the control and data plane, they were on the same device as we said before. You need to get and attach, you need to get closer to each of one of these devices and and connect via an Ethernet cable, and then control, change the settings, do customization, whatever you want. As you can see, with each blue data plane, which is router or switch or whatever, you have a control plane attached with it, and you need to configure it and adjust the settings so that you make it behave the way you want it. In the software-defined networking, you have one centralized controller machine, and all the other devices are programmable, and you can remotely program them and like configure them in such a way that they do the functionality you want them to do. What are the security issues related to software-defined networking? We have the centralized controller is a potential single point of attack or failure. This is very serious. I told you in softwareization, you take the control into one device, the control plane, and this device can remotely configure the machines, which could be routers or switches, to behave in a certain way based on the commands that are being sent. But since we have just one server that's controlling all these devices, if something happens to that server, the whole network, all the other devices will malfunction, will stop working properly. We have also the southbound interface between the controller and data forwarding devices is vulnerable to threats that could degrade the availability, performance, and integrity of the network. And hackers can install compromised application on the controller via northbound interface. Controllers application are built on general purpose computing platform which have vulnerabilities. As I told you before, in the old days, the software and hardware, they were coupled together and they were proprietary. But now the software is something and the hardware is something, and you could buy the hardware from the market from any provider or vendor, and you don't know the vulnerabilities that can come just due to using a certain hardware. Five, we have forged or faked traffic flows to overload the data plane switches. And six, we have eavesdrop, modify, or destroy the ongoing data traffic. So these are all issues that need to be addressed, and all these issues are related to software-defined networking. What about network function virtualization? Network function virtualization, a concept of transforming of the hardware-based network function into software or virtual function. So in the old days, you had for each server, for each application, you had the specific hardware. Like for message routing, you have a hardware. For CDN, you have a hardware that's different. For session border controller, you have a different hardware. For WAN, you have a different hardware. For firewall, you have different hardware. For each and the new service you provide to your network, you use to create a new hardware. But now with the concept of function virtualization, you don't do that. You just have one generic hardware like that composed of computational resources, storage and RAM and switches, router, functionality, whatever. And all to convert this into any of the previous devices, you just change the software. And the goal here is to separate network functions from the underlying hardware so they can run on the standard hardware. Such software-based, which is virtualized network function, is called virtual network function. So this really reduce also the cost as well. What are the security issues related to network function virtualization? We have attacks on Nano, malicious misconfiguration, excessive log attacks, log leak attacks, privilege escalation, steal data from ephemeral storage, and so on. Attacks on VNFs, interoperability issues, denial of service, software flaws, VM escape attack, VNF manipulation attack, VNF location shift attack. Of course, these each one of these attacks needs, especially the new ones, need uh, need extra slides to explain. But now this is not the main topic of the course right now. We cannot go through all the possible attacks that can happen due to network function virtualization. But here we mentioned them quickly for you to be aware that just by implementing the virtualization feature technology in 5G brings new security attacks. And those are among the attacks caused by network function virtualization. We have also attacks on VMs, virtual machines, VM migration attacks, side channel attacks, schedule attacks, lack of isolation. We have attacks on hypervisor, VM guest operating system manipulation, isolation failure risk, exhaustion hypervisor, exceeding logs through a troubleshooting failure. We have attacks on physical hardware, disk failure, physical attack, code execution on the physical host, state manipulation attack, resource interference attack. Imagine how many attacks we have just because we implemented a new technology called network function virtualization. So introducing new technology is good in terms of bringing new benefits and new advantages and new possibilities that didn't exist before in the previous generations, but it always comes at the expense of bringing uh, new drawbacks, new side effects, and these are among these side effects. And we also explained the multi-access edge computing, where you move the computing from the data center, the cloud, and to make it closer to the devices, the end devices, by placing it at the base stations, which are the closest access points to the end devices, where storage, processing, and so on are moved closer to the base stations, interacting uh, with the end devices like uh, mobile devices, vehicular devices, cameras, or whatever. Why do we need the MEC? Of course, to reduce the delay, make the interaction faster, and avoid single point of failure, and so on. So latency, jitter, limited access, bottlenecks, localization and awareness, insecure data outsourcing, all these are reasons why we use MEC. So So the advantages of MEC: ultra low latency, localization awareness, and proximity data outsourcing, improved capacity at the edge, higher bandwidth, and real-time responsiveness. Uh, Even when you are building a website and you want your website to be fast, you need to use something called CDN, uh, Content Delivery Network, which means that instead of keeping the static files of the static files of your website stored in a very far server, you could just make them closer to the end devices who are using your application by storing them near in data bases or data centers or servers that are closer to the edge network. And why is it important? Security at the edge. Edge is the weakest ingress point to the originated services in the RAN, credibility of Internet of Things devices, weak embedded encryption, encoding schemes due to market competition, decentralization of MAC codes, and moving the data to the close proximity are increasing the probability for exploitation. Service impeding attacks like denial of service and distributed denial of service, privacy, integrity, and the trust management, as well as security of virtualization technologies. These are reasons why security is important in Mac. Okay, any questions about this?